Hello everyone and welcome to my channel. In this video, we're going to learn to add JWT authorization to our FastAPI applications. Before we get started, I would like to ask you to subscribe to my channel. It's a small action, but it goes a long way to support me to continue making this kind of videos. Now, in this video, we're going to learn to add JWT authorization to our APIs. And notice that I say authorization and not authentication. JWTs are tokens that contain claims about the right of a user to access our API. It doesn't authenticate the user. It doesn't identify the user. They just tell us whether they have access or not. Authentication is a different process, which is the process of identifying the user, and as a consequence of the identification process, we issue a token to the user. So the server that actually issues the token is the authentication server. And we will talk about this in a different video, and we will see how we can implement this using FastAPI. But in this video, all we're going to do is build a layer in our code that intercepts the JWT from the request headers and validates the token. And then we're going to get the user ID from the token, and we're going to inject this ID into the state of the request object so that we can reuse this value in our view functions later on. We're going to see how to do that, and in a later video we're going to put this all together with a user table so that we can validate access from a user to specific records in the application. Now we have a lot to do, so let's get started. So I'm here in the terminal and I created a folder called FastAPI JWT auth. The first thing we want to do is to create an environment and install the dependencies that we're going to need to work in this tutorial. So to create the environment, I'm going to use pipenv, and what you need to do is run pipenv -- Python and point to the specific Python executable that you want to use to work in this environment. So we run this and this creates the environment for us. Alright, so the environment has already been created. The next thing we want to do is to install the dependencies. I'm going to show you the contents of the pip file to see which dependencies we're going to use in this project. So we're going to use FastAPI, which is the framework we're going to use to build the API. We're going to use uvicorn, which is the framework that we're going to use to execute the web server. We're going to use PyYAML to load the OpenAPI specification. We're going to use PyJWT to validate the tokens, and we're going to use cryptography to manipulate the signing keys of the tokens. You can copy this file directly from the repository. You have the link in the description for this video, or you can install the dependencies directly running pipenv. To install these dependencies, what we do is run pipenv install --dev, and we use dev because we are using a dev dependency as well. We are using black to format our files, and to make these dependencies compatible with each other, we are going to allow also to install pre-releases. This is going to be necessary for black. So we do this, and the dependencies are now installed. We are ready to go. Now, one look at the files that we have here. So we have a FastAPI application already built here. This is the result of the FastAPI tutorial that I produced last week. You can check out the link in the description in this video. If you have previous experience with FastAPI, you can just look at those files. If you don't have experience with FastAPI, check out my FastAPI tutorial. It explains everything you need to know to get this API up and running. So those are the API.py file, is the file that contains the implementation of the API endpoints. That is also the schemas.py file, which contains the definitions of the Pydantic models, which run validations on the payloads, which are exchanged through the API. And that is server.py, which contains the instance of the FastAPI application. So those are the files that come from the FastAPI tutorial. We also have the OpenAPI specification that documents how the API should be implemented. And we also have a JWT generator. This is a file that we are going to use to produce JWTs so that we can play around with the application once we have added our authentication layer. We implemented this file in my JWT tutorial a couple of weeks back. Take a look at the file. If it doesn't make sense to you, you can check out the JWT tutorial. It explains everything you need to know to understand that file. I'll put the description of that tutorial in the description of this video. We also have a private signing key here, which is used by the JWT generator to produce the signed tokens. And we have the corresponding public key, which we're going to use in the API to validate the token signature. We also have an auth.py file, which is where we are going to implement our token validation logic. So let's go to that file and see how we do that. So our token validation is going to be implemented in a function called decode and validate token. And this function takes one parameter, which is the access token itself. Now, the first thing we want to do in this function is to retrieve the unverified headers from the token. We retrieve the unverified headers using JWT, so we import the library. And the reason why we are retrieving the unverified headers is because we're going to use them in the token validation process. Oh, there's a typo. It should be unverified header. The next thing we're going to do is to load the public key. And to do this, we're going to use cryptography's library to parse the key, and we're going to use Python's pathlib library to load the key from the file. So let's see how we do that. Public key equals load PEM X509 certificate. The reason for the name of this function is because these keys are known as X509 certificates. So what we need to load here is the public key, which is within the same folder as this file. So we can say parent public key.pem. And we need to wrap this in parentheses so that we can call a method here, which is read text, which is going to read the text from the file. And then we're going to pass the text to this function from the cryptography library, which is going to allow us to build a public key object, which is what we need to verify the token signature. So it works like that. All right, all the dependencies are imported. The next thing we need to do is we need to use PyJWT's decode function to decode and validate the token. It works like this. Now, what's going on here? So when we call the decode function, the first thing it does is it tries to validate the token. If the token is valid, we get back the token's payload. If the token is invalid, PyJWT raises an invalidation error and we don't get the payload back. Now, in terms of validation, we're passing the access token itself. We're passing the public key that has to be used to verify the token signature. We are reading the algorithm that has to be used to verify the token directly from the token header. And the reason for this is because we don't want to make assumptions about which algorithm was used to sign the token. We want to let the token tell us which algorithm has to be used. And then there is another parameter for the audience. And this has to be the same value for the audience that was used when we generated the token. So let's take a look at that function and see what it looks like. So in this function, we are creating a token with this payload. The issuer is set to an authentication server called auth.coffeemesh.io. For those of you who are wondering, CoffeeMesh is the example of application that I used throughout my book, Microservice APIs. We are going to use a random UUID as an ID for the user of this token that is under the sub property. Then the audience is here, and we're gonna say that this audience should be to-do, which is the API for which we are adding the authorization layer here. And then we say when the token was issued at time is this property. We're setting the expiration time of the token within 24 hours. And we are also going to say that this token was issued using the OpenAPI Connect protocol. What else is happening in this file? We're using the private signing key to sign the token. So first we read the key from the file, and then we get the private key object using the load pen private key from Python's cryptography library. The key is not password protected, so we don't need to specify any password. And finally, we use JWT to produce an encoded token with these parameters. We are using the RS-256 algorithm to sign the token because we are using a private key. If we were using a secret, we would use a different type of algorithm. So the important thing here is that audience has to be set to the same value that we use in this file. So let's go ahead and copy this here. All right. So we have the token validation logic in place. The next thing we need to do is to make use of this function in the API. And to do that, we're going to create an authorization middleware for FastAPI. Let's see how we do that. So we go to our server file and we define a class called authorized request middleware, and this has to inherit from starlet space HTTP middleware. Now, the most important method in a starlet middleware is the method called dispatch. It's an asynchronous method, and it's the method that FastAPI and starlet are going to call to execute the middleware. So we define that method. Now, the signature for the dispatch method is already defined in the base class, so our text editor is able to read that signature and populate our method with a single click here. So what does the signature look like? We have a parameter for the request object, which is going to be passed to our method so that we can inspect a request and perform any actions or validations we want to do on it. And we have a callback. Now, what's this callback? Our server has a collection of middleware, and this middleware is just one of many middleware that can be executed in a chain. So call next is just a reference to the next middleware in the chain that has to be called to continue processing the request. Let's import these classes now. All right, so the first thing we want to do is to check if the request is coming on a public path or not. For example, the documentation endpoint of the API, which serves the OpenAPI specification or the Swagger UI, we don't want to protect those endpoints because those are the endpoints that users have to see to learn how to integrate with our API. So we're going to exclude those endpoints from the validation process. So we say if request URL path in docs or OpenAPI JSON, then just return a call to the next callback with the request. All right, so that's the first thing. The next thing we want to check is whether the request is an options request. Now, what is an options request? It's a preflight request. This is a request that browsers make to the server to learn which HTTP methods, HTTP headers, and origins are allowed by the server. And the HTTP specification says that preflight requests should never be authorized. So we're going to exclude those requests from the authorization process. So we say if request method equals options, then return await call next request. Now, if we are out of those cases, the next thing we have to do is try to validate the request by intercepting the JWT from the request headers. So the first thing we're going to do is check if the token is present in the headers. So we say better token equals request headers get authorization. The access token always comes in a request header called authorization. So we try to get this value from the headers, and we say if the value isn't there, if not better token, then we are going to respond to the user with a 401 response, meaning the user is not authorized to access the request because we can't find any authorization element in the request. So that is return JSON response. And we say the status code is status HTTP 401 unauthorized. We import the status from starlet. And then the content is going to be the detail is missing access token, and the body is missing access token as well. So we're just telling the user that the token is missing from the request. So that's the first check. If the token is not present in the request, we reject the request with a 401 response. Now, if the token is present, we're going to try to validate the token. So we say try auth token equals better token split. We fetch the second element and we strip any possible white space or something around the token. Now what's happening here is authorization JWT headers are better tokens. Better tokens are tokens that contain two elements. The first of them is the better keyword, and the second of them is the token itself. They're separated by a space, so that's why we're going to use a space to split the elements in two, and we're going to fetch the second element, which is the token itself. And then we're going to say token payload equals decode and validate token auth token. And this is the function that we implemented earlier. Now, if the token is invalid, JWT is going to raise an exception, and we want to catch those exceptions so that we can respond to the user with a meaningful response instead of ending up with a 500 generic server error. So we're going to catch the most common exceptions which are raised in the context of a JWT validation. So we're going to say accept all of these exceptions. Let's import these classes. And we say accept any of these exceptions as error. And we're going to reply to the user with a JSON response with a status code 401. And the content is detail stringified representation of the error, and the body is also a stringified representation of the error. Alright, so this is the token validation step itself. If there is an exception, we reply to the user with a 401 response, and if there is no exception, we're going to continue processing the token. So we're going to say this is a try except block. So the proper way to continue if there is no exception is using an else. So using else, we say request state user ID equals token payload sub. Now remember, the sub property of the token payload represents the user ID. So we're going to store this value in the state object of the request as a property called user ID. We're going to be able to access this value in the view functions later on, and I'm going to show you how. So we do this, and the next thing is return await call next request. So we're going to pass the request to the next callback. Now the next thing we have to do is to register the middleware with FastAPI. So we say server at middleware authorized request middleware. There is another way of defining middleware in FastAPI, which is using a FastAPI decorator, which makes it slightly easier. But if you're building more complex middleware, which may need additional methods and properties and things like that, you may be better off using the class type of middleware, which Starlet allows you to create. Now that is for the authorization middleware. Now in the context of APIs, something very important is cross-origin requests. And this is when we may have requests to different domains with our application. So we may have requests to our server which are coming from a different domain. To enable those kinds of requests, we need to register a CORS middleware. And I'm going to show you how we do that. We say server at middleware CORS middleware, and this is already defined in Starlet, so we just need to import it, and we need to give it some configuration. So we're going to say allowed origins equals all of them. We're going to allow all origins in the API. Allowed credentials is going to be true. Allowed methods is all of them, because we use different types of methods in the API, and allowed headers is all of them as well. If you're worried about giving too much freedom to your users about which headers they can use or which methods they can use, you can be specific in this configuration, but otherwise you can just allow all methods and headers into your API. About the origins, you have to make sure you only allow trusted origins, and that is usually your own origin and perhaps some other origin that you trust. The final thing we have here is we're importing the API views from the API module so that they can be registered when the application is starting up. So our authorization is already built, and we can already start playing around with things. So let's start the server and make some requests. So the first thing we want to do is to activate the virtual environment. The dependencies are already installed, so what we need to do now is use uvicorn to run the application, and that is going to be giving uvicorn the path to the instance of our server, which is in the server file. And we're going to use the reload flag to make sure the application reloads if we change the files. And it's telling us that we made a mistake here. The configuration we passed to the CORS middleware is wrong. The parameters are not allowed origins, allowed credentials is allow. So let's fix that first of all. And the server is automatically reloaded because we are using the reload flag. So we are able to start using it now. Now let's visit the documentation endpoint in the application. So that is going to be localhost 8000 docs. And let's try and make a request and see what happens now. And we get the full once response telling us that the request isn't authorized. And that's because we haven't included the token in the request header yet. To be able to add the token to the request, we're going to change the request header so that we can add it here in the Swagger UI. Let me show you how we do that. So we open the OpenAPI specification, and here down in the components, we're gonna add a new definition here, which is called security schemes. And we're gonna add a security scheme for better authentication. So that is going to be, we're gonna call it better auth. And we need to define the better authentication in this object. So this is a type HTTP. The scheme itself is better. And the better format is JWT. So that is the security scheme definition of our API. Now we need to register our endpoints with this security scheme so that the UI knows when to inject the header in the request. So that is going to be security. And to register the endpoints have IDs, operation ID, get task for the get to do endpoint. So we're going to register them with the IDs. So we're going to say better auth registers get tasks, create task, get task, update task, and delete task. All right. Now this is our own custom OpenAPI specification. This is different from what we have implemented in the code using FastAPI, so we can't use any longer FastAPI's generated documentation to interact with the UI. We have to tell FastAPI to use this design that we have made. And to do that, we're going to go to the server file, and right here we're going to load the OpenAPI specification. So we are going to say OAS documentation is YAML safe load path with reference to the current file parent oas.yaml, which is the file that we have here together with the rest of the application. We're gonna read the text, we import path, and we also import YAML. So we read the text of the specification and we pass it to the YAML loader so that we can parse it and turn it into Python object. And the next thing we're going to do is we say server OpenAPI equals lambda was doc. And that's all it takes to overwrite the default mechanism in FastAPI for generating OpenAPI documentation. If we reload this page now, there is an authorized button here that we can use to inject tokens into our request headers. So the first thing we're going to do is to generate a token using the token generator file that I showed you earlier. So that's going to be Python JWT generator. And here we have a token. Now, if you're curious about the contents of the token, they are exactly the same as what I showed you earlier, but you can validate the token contents in this website, jwt.io. You paste the token here on the left, and you get the decoded values on the right panel here. So the token is looking good. Let's use it now to authorize our requests. So we start the server again, and now we use this button to inject the token here. We say authorize, we close it, and we use the get endpoint now. We execute it, and there is an error. Cryptography doesn't like the way we are passing data to its function to load the public key. So let's take a look at that. We go to the auth module here, and what's happening here is we are passing to cryptography the raw contents of the file. This isn't good because cryptography doesn't know which encoding mechanism has been used to save the contents to this file. So we need to make sure that we encode the contents of the file with UTF-8. Now we do that, the server is reloaded because we are running it with the reload flag, and we reload this UI. We paste the token again here, close, try out, execute, and now it's telling us that the audience is invalid. Let's see why. Oh, and the reason is because we haven't specified an audience at all. So let's go ahead and specify one. Audience has to be the same audience that we used in this file. So let's put that here. I have a feeling that we actually did it. Maybe I deleted that line accidentally. So we have the audience now. Now we should be able to send a valid request to the server. And it is. Right, so this is a successful authorized request. Now what we've done so far is to validate that the token which is coming in the request is correct. And we are also saving in the requests state object the ID of the user. Remember, that happens in the middleware right here. Now what we can do is we can retrieve this value in our view functions to perform additional authorization on the user who's trying to access resources from our API. So let's see how we access this value in our view functions. Okay, so we are going to have another tutorial to explain more in detail how we manipulate those values in our view functions and how we modify our database so that we can save relationships between our users and other records so that we can perform additional validations to see if a user is trying to access something that belongs to them or not. But just to complete this first part of the tutorial, let's just see how we access this value here. So let me show you how we do that with the example of this getToDo function. And in the next video, we will do that for the rest of the endpoints. So what you do here is we define a parameter called request, whose type is request, the request class from Starlet. And actually there are no additional parameters, so let's leave it in a single line. And now in this context, what we can do is we can access the value of the user from the request state. To show you how that happens, let me put a breakpoint here. The server is reloaded. Let's do another request. Now we are here in the breakpoint and we can inspect the request. So we can do request state. This is the request state object in which we saved the user ID before. So now we can say user ID, and it gives us the ID of the user that we saved earlier when we were processing and validating the JWT token. So this is how you will access information from the request state object. And you can save any additional information that you need in your middleware into this object, and you can access it in your API views. So let me exit this. So what we would do is we would say user ID equals request state user ID. The next thing we could do is we could query the database for those records that only belong to this user. And when we create a task, we make sure that the task is linked to that user. And when we get the details of the task, we make sure that the task actually belongs to the user. Otherwise, we would send a 401 response, meaning that the user is trying to access something they are not authorized to access. So this is really how you add JWT authorization to your FastAPI applications. This is everything I wanted to say. If you like this video, please make sure you click the like button, make sure you subscribe to the channel, and I would also appreciate if you can share the video with your network, with your colleagues. All of those things go a long way to supporting me to continue producing this kind of content. If you like this video, you will also like my book, Microservice APIs, which I'm writing for Manning. This is a book exclusively dedicated to teaching you how to design and build microservices and APIs, full with examples in Python. If you're interested in this book, check out the description in this video. I'm including a link where you can download 2 chapters of the book for free. I will also include a code which you can use to get a discount from the price. And I will also include the URL of the book where you can get a copy of it if you're interested. That's everything I wanted to say. Thanks so much for listening, and see you soon.